Okay, so we have a dog walks northeast 15 meters. Northeast means 45 degrees from the horizontal. So here's my 15-meter vector, and I know that it is 45 degrees from there. And then we go another 25 meters due east. The resultant vector goes from where you start your diagram and points directly up to the finish. Now, I can't use Pythagorean's theorem because there isn't a right triangle in here, so I have to do something else. It's called using components. Now, this angled vector, the 15 meter, has a vertical component that sticks straight up, and it's going to have a horizontal component that moves straight across. Now, because this angle is 45 degrees, I know that this one is also 45 degrees, so I can use trig to find the lengths of the adjacent side, which I'll call y, and the side opposite my angle I'll call x. For the side that's opposite, I know that the sine of 45 degrees is the opposite side over the hypotenuse. So that gives me x is 15 sine 45. And then I can do the same thing for this adjacent side. Cosine 45 degrees is y over 15. So y is going to be 15 cosine 45. Sine and cosine of 45 are the same, so if I plug in my calculator 15 sine 45, I get 10.6, which means that this is also going to be 10.6. If I put those two numbers on my diagram, I realize that this green line is now the hypotenuse of a very large right triangle. I can find the length of that green side using Pythagorean's theorem. So I know that this is going to be the square root of one side squared, which is going to be 10.6 squared, plus the other side squared. This is going to be the sum of the original horizontal vector and the component that I found. So that's going to be 35.6 squared. Calculate that out, and you got your answer.